In this lecture, I am going to discuss about the numerical example based on the multiplication property of the Fourier transform. In the previous lecture, I have proved that a Fourier transform of any signal x1t is x1 omega, and Fourier transform of any other signal x2t is x2 omega. Then, by using the multiplication property of the Fourier transform, you can determine the Fourier transform of signal which is the multiplication or product of x1 and x2t. And according to multiplication property, which I have proved in the previous lecture, its Fourier transform will be 1 by 2 pi of x1 omega convolution x2 omega. Here x1 omega and x2 omega are the Fourier transform of the signal x1t and x2t. So by using this property, you can determine the Fourier transform of the product of two signals. That is, if you know the Fourier transform of x1t and x2t, then you can determine the Fourier transform of their product by using multiplication property. Let us consider one numerical example to understand this property. Let us consider the question is find Fourier transform of e to the power minus t sine omega ct ut. The question is determine Fourier transform of the signal e to the power minus t sine omega ct ut. How you will determine the Fourier transform of this signal using the multiplication property, for which let us assume x1t is e to the power minus t ut, and x2t is sine omega ct. Then this xt will be the product of x1t and x2t. So this signal is the product of two signal. One is e to the power minus t ut and another one is sine omega ct. Now, if you know the Fourier transform of this and this, then using the multiplication property, you can determine the Fourier transform of their product. Now, if x1t is e to the power minus t ut, then what will be the value of x1 omega? In the previous lecture, I have derived the formula Fourier transform for e to the power minus t ut, and which will be if x1t is this, then Fourier transform of x1t will be e to the 1 by 1 plus j omega. And we have also derived the Fourier transform of the sine omega ct. And Fourier transform of sine omega ct, which I have derived in the previous lecture. So go through that lecture. The Fourier transform of the sine omega ct will be pi by j Fourier transform of the signal sine omega ct will be x2 omega, which is equal to pi by j and delta omega minus omega c minus delta omega plus omega c. This is the Fourier transform of the signal sine omega ct. So first you will have to write this signal in product of two signals, and after that you will have to determine the Fourier transform of each individual signal. Now, according to the multiplication property, if Fourier transform of x1t is x1 omega and x2t is x2 omega, then Fourier transform of their product will be this. So, Fourier transform of x1t into x2t will be 1 by 2 pi x1 omega convolution x2 omega, and it will be equal to 1 by 2 pi, and here x1 omega is 1 by 1 plus j omega, and convolution x2 omega is pi by j. You can write pi by j here. You can keep pi by j outside this bracket, pi by j into, pi by j into this. So 1 by j omega convolution x2 omega will be delta omega minus omega c minus delta omega plus omega c, and this pi by j will be here. Now you can separate these two terms. This pi and this pi will cancel to each other, and this is 2 by j, and inside the bracket it will be 1 by 1 plus j omega convolution delta omega minus omega c minus 1 by 1 plus j omega convolution delta omega plus omega c. And as you know, when you will convolute any signal with delta omega minus omega c, then this omega will replace with omega minus omega c. So this will be 1 by 2j, and this become 1 by 1 plus, in place of j, in place of omega, it will be omega minus omega c minus 1 by 1 plus j omega, and in place of omega, the term will be omega plus omega c, because you are convoluting the signal 1 plus j omega with delta omega plus omega c. So this omega will replace with omega plus omega c. And now you can solve this expression to find out the Fourier transform of x1 t into x2 t. So I have discussed this numerical example in this PDF file. So go through this PDF file, and you will get the Fourier transform of the signal. This signal e to the power minus t sine omega ct ut will be this. So in this way, using multiplication property, you can find Fourier transform of the signal, uh, which is a result of the product of two signal. In next lecture, I will discuss conjugate symmetry. What is the meaning of conjugate symmetry of Fourier transform?